So I want to talk about annuities. We've been talking about single payments, but what if we have multiple payments spread out over time? So an example of that is an annuity. An annuity is a finite series of fixed payments spread out evenly over time. So for example, you receive $1,000 at the beginning of each year for the next 5 years. A car loan, which requires payments of $250 per month for the next 5 years. A pension, which pays $3,000 per quarter for 25 years. Right? These are finite fixed payments spread out over time. So using the time value of money concepts, we can calculate the present or future value of an annuity. Example. So in this example now, unlike our earlier ones where there was only one $1,000 payment or one payment in the 3 years, in this example we have 3 $1,000 payments spread out evenly over these 3 years. So in year 1 we're going to receive $1,000, and in year 2 $1,000, and in year 3 $1,000. So now given an interest rate of 8%, what is this stream of 3 $1,000 payments spread out over 3 years worth today? So, for example, at first pass, you can say, well, I'm going to get $3,000. So it's worth $3,000. And my question would be, well, would you be willing to pay me $3,000 now to receive from me $1,000 next year, and then $1,000 the year after that, and $1,000 the year after that? And the answer, hopefully, is no. You wouldn't be willing to do that. And the reason is because you'd be losing all this interest. So we have to account for the time. All right, so how do we do this? Well, we need to discount each of these terms individually. So the first term is simply $1,000 divided by 1.08 to the first. That's $926. So the second term is 2 years out. So we need to divide that by 1.08 to the second. And that's $857. Then the third payment is 3 years out. So we need to divide that by 1.08 to the third, which is $794. So now we have these 3 individual payments. It's as though we calculated it using the previous method. Each calculation was separate. Now we add the present values together. So we take our 926, our 857, and our 794, and we get 2577. So this annuity is worth $2,577 today. In other words, you'd be willing to pay me $2,577 today if you knew, with 100% certainty that you'd be receiving $1,000 from me as specified here. So I want to just rearrange these terms, the 1 divided by 1.08 to the first, second, and third, and just put them in the present value factor notation, just to show you a little bit how this works. So we divide, just converting it based on the math from the earlier slide. So we can say that each term is being multiplied by its present value factor, $1,000 times 0.926, 0.857, and so on. And that's just right. $1,000 times, for the first term, the present value interest factor of 8% to the first. The second term is the present value interest factor of 8% to the second, and the third is to the third. It's just notation. So another example of what we just saw. So the present value of this annuity is equal to $1,000 times, and each of these terms next to them is simply the present value interest factor associated with that payment. So it's 1,000 times, right, I'm just going back to the previous page. You'll see the 0.926, 0.857, and 0.794. in these horizontal lines. And that's all this is, $1,000 times 0.926 plus $1,000 times 0.857, etc. And this reduces to 2577, which is what we had seen in the previous slide. So a summary of this method is simply the present value of the annuity is equal to the sum, and then we calculate each of these payment times their present value factor. Alternatively, this is the exact same equation as the previous slide. We can draw out the $1,000 from each of these terms because it's common to them. So it's really just the $1,000 times, and then we can add up the present value interest factors, 0.926 plus 0.858 plus 0.794. And that's just $1,000 times 0.2577. The math is identical. I'm just rearranging terms a little. So that's the present value of the annuity. Is now we just have in the previous slide we first calculated each term's payment times its present value interest factor, and then we added them all up. And in this example, we take the payment out and we just add up the present value interest factors, and then we multiply it by the payment. Again, it's two ways of saying the exact same thing. So another example here. What is the present value of 8 annual payments of $7,500 starting at the beginning of next year? So assume an interest rate of 12%. So the key here, 8 payments, $7,500 each at 12%. So now 8 payments is a little too long for me to use this time chart, this timeline chart that I was using. That would extend beyond the monitor and into your bookshelf. So I'm going to have to do it another way. Well, I'm going to do this in Excel. And I've done this in Excel, and I've just copied and pasted the results here into this presentation. So in this case, I've just summarized at the top, $7,500 per payment per year, 8 years, interest rate of 12%. Now, the first column, I'm just going to open this up one column at a time just for this example. So the first column, we've got our years 0 today through 8. Next, we have our payments. This is an annuity, so every payment is, by definition, identical. We receive $7,500 in each year 1 through 8. Now, the next term is the present value interest factor. And this one is going to change. So what is this? Again, this 0.893 is going to be 1 divided by 1 plus the interest rate to the first. So in this case, it's 1 divided by 1.12 raised to the first. And that's 0.893. We then raise it to the second. 1 divided by 1.12 to the second. That's 0.797, and so on all the way to the bottom. Our last term is 1 divided by 1.12 raised to the 8th. And when you crunch that, you get 0.404. Right? So that's all these calculations are. This is the present value interest factor calculation that we've been building up. So now what do we do with all this? Well, we multiply each payment by its corresponding present value interest factor, which effectively discounts those payments based on how far it is out. So, for example, in year 1 next year, $7,500 times the discount rate times the present value interest factor of 0.893 equals today $66.98. So $7,500 next year is worth $66.98 given a 12% interest rate. We can keep doing this for each year. So just to show you the bottom year, 8 years out, $7,500 is really only worth $3,030 today. So that might seem a little surprising. Well, it's $7,500, you say. Well, my answer is it is, but that's in 8 years. If you were able to earn 12% interest on that in the intervening years, it's really only worth $3,030 today. Okay, so you're convinced. Now, how do we get to the final value? Well, we just add up all these present values. $37,260. Right? So when you have an annuity, this annuity of 8 payments of $7,500 is worth $37,260 today. So just to restate this, if you add up all these payments, $7,500 for 8 years straight is actually $60,000 that you'll be physically receiving. However, you'd only be willing to pay today if you were to pay for this. If you had the choice, I'll give you $60,000 spread out in $7,500 evenly for the next 8 years. Every year you get $7,500. Or I'll give you $37,260 today. Which would you choose? It's a little like winning the lottery, a very small lottery. You would choose, I don't care. I'll be equally happy with both. You can pay me $37,260 today, or I'll just wait for the payments to come in. Obviously, this is ignoring taxes or any other issues. This is just based on this concept.